So here on example 2, we're going to do the same thing, but just slow it down a little bit so you can see it. So it says find the derivative of the function f of x equals x to the fifth. And so the power rule, what is stating up here, the power rule is simply that if you're looking for the derivative, you take your power and it becomes the constant or multiplies times the constant in the front, I should say. So this would be 5x, and then the power, you just subtract by 1. So 5 minus 1 is 4. And that would be the derivative of this function, which would find our instantaneous velocity or rate of change and such like that we were finding last lesson. Okay, so part B here, it says g of x equals 4th root of x to the 6th. So a very important conversion you need to know is that if g of x is the 4th root of x to the power of 6, that means g of x could also be written as x to the power of 6 divided by 4. You could rewrite it that way, which in turn we could simplify. 6 and 4, they both could be reduced. The value of 2 goes into both of the numerator and denominator there. You could rewrite that as 3 halves. You reduce that. Okay, so what would g prime be? G prime, you would take your 3 halves and move it to the front. 3 halves goes up front. And honestly, I shouldn't be writing that up there because it looks like I'm changing the equation g, and I'm not actually changing g here. So it would be 3 halves x, and then you would subtract this by 1. So 3 halves minus 1 is like subtracting 2 halves, which gives us 1 half. And that you could also rewrite, so 1 divided by 2, that's a square root. You could write this as 3 halves square root of x. That 1/2 power is only on the x, it's not on the 3 halves. That's why they had the 3 halves outside the square root. So you could write it that way. Here's part C. It says h of x is equal to 1 over x to the 10th power. So again, another rule on powers for you to know is that if you have a variable with the power in the denominator, that's the same thing as just having a negative power. You could rewrite this as 1x to the negative 10th power. And so since it's 1x, you don't need the 1 there anymore, that coefficient, it's gone. So what does that mean for my problem? Is I could say h prime, the derivative of h, is going to be take that negative 10, move it to become the constant, and then I subtract 1. Now be careful. Negative 10 minus 1 is not negative 9. Negative 10 minus 1 more, if you think of a number line, if here's 0 and you go all the way over and say that's negative 10 there, if you subtract 1 more, you actually go to negative 11. So this would be to the negative 11th power, which you could rewrite this as negative 10 in the numerator divided by x to the 11th power. You could write it in this form there. And that would be our derivative. So with that, I'm going to allow you to work on this problem. I've put together a few pieces. So just think about this as being x to the 1st power, the 3rd root of x to the 1st power here in the denominator. Remember, this means a dividing power of 3. That's like dividing the power by 3. Pause the video if you need more time.